The first cash flow we'll talk about is the cash flow to creditors. And it's written as CF, standing for cash flow, parenthesis B. Now this B stands for bondholders, and we'll get to why that is in just a little bit. Now keep in mind this is cash flow to creditors. Interest is definitely a cash flow to creditors. Interest is the rent we pay on borrowed money. And then we're going to subtract out any additional borrowings we might have done. And we are calling this net new debt. But it's actually net new long-term debt. Now there is a mathematical proof that shows why it is long-term debt versus total debt, and I'm always pleased to share that. But for most students, it's enough just to know that it is long-term debt. Now, how do we find net new long-term debt? Well, we start with the ending long-term debt and subtract out the beginning long-term debt. So what is the first thing algebraically we'd like to do to simplify this thing? Well, I want to distribute this minus sign. Notice as I distribute the minus sign, it changes this minus to a plus. Now that we have it all distributed out, we can solve for several things. We could solve for net new debt. We could subtract both of these from both sides. And subtract CFB, or cash flow to creditors, from both sides. What if we wanted to find interest? Notice this is net new debt. Actually, net new long-term debt. And so we can solve this thing for several things. Now, you could go back here and add beginning long-term debt to both sides and get ending long-term debt. You could arrange this any way you like. The key to doing this is to remember that if you move something across the equal sign, the sign changes. For example, when we moved positive beginning long-term debt across the equal sign, it changed to negative. And when we moved negative ending long-term debt to the other side, it became positive. We can do similarly for the cash flow to shareholders. Just as interest is a cash flow to bondholders, dividends are a cash flow to shareholders. And then we need to subtract out any additional stock, net, that was issued by the firm. And so this is actually net new stock, in the same way that it was net new long-term debt for the cash flow to bondholders. Now, what are these things? Well, let's talk about stock issued. Stock issued is just the increase in common stock and capital surplus. Due to some weird accounting rules that I can't claim to understand fully, when you issue a new share of stock, the part of it that is valued at par goes into the common stock account, and the remainder goes into the capital surplus account. And so in order to know the total amount of money that was raised by issuing stock, we have to find the increase in both of those accounts and add them together. Now, what about stock repurchased? You can tell how much stock was repurchased during a period by the increase in the treasury stock. This is found on the lower right-hand side of the balance sheet. Whenever the firm repurchases stock, the amount of money they spend to repurchase the stock winds up in this account, the treasury stock account. And so by simply looking at the increase in that account, we can find out how much stock was repurchased. And so when we look at how much stock was issued and subtract out the amount that was repurchased, that gives us the net new stock that was outstanding as a result of these two activities during the period. Now let's see what we can do with this equation algebraically. The first thing I'm going to do is distribute this negative sign over here into the brackets. Notice that minus times minus is plus. Minus times the plus that's there is minus. So that's how we do that. Now we can manipulate this thing around and find different things of interest. For example, what if I wanted to find dividends? And notice when we do this, that this piece over here is net new stock. We could also find how much stock had been issued. So once again, we can solve for any one of these variables as long as when we move across the equal sign, we change the sign. So for example, dividends here was positive, so CFS was across the line from it and was positive. Now that they're together, CFS has to have the negative sign in front of it. So where does the cash flow come from to send the cash flows to the bondholders and the shareholders? Well, it comes from the assets of the firm. And why are the bondholders and the shareholders the ones who get that cash flow from the assets? Because they are the investors who are putting their money at risk in order to finance those assets. And so this makes perfect sense. But let's talk about where CFA, the cash flow from assets, comes from. It actually comes from operating cash flow minus net capital spending minus the change in net working capital. Once again, in science, engineering, mathematics, and finance, the delta, or triangle there, stands for change. And so this is the change in net working capital. So what do these independent pieces mean? Well, let's talk about operating cash flow. And keep in mind, in finance, we are concerned about cash flows. And in finance, we do not consider interest to be an operating cash flow. This is one of the major differences between finance and accounting. So what can we do here? Well, we'll start with the earnings before interest and taxes. And so interest is not in there, but we will need to do something with the taxes. And then we are adding back depreciation. And the reason we are adding back depreciation is because it is a non-cash expense. And then we are subtracting the taxes, because after all, taxes are a real cash flow. And so it gives us our operating cash flow. What about net capital spending? Well, it is just the ending net fixed assets minus the beginning net fixed assets plus depreciation. Now, why would this be the case? If you look at these two, you would think that the change in the amount of investment in net fixed assets, if we just take the ending amount and subtract the beginning amount, we would be just fine. Except for one thing. This happens one period before this, and that means there's been one more period of depreciation recorded. And remember that depreciation is a non-cash expense, and we're looking for a cash flow for net capital spending. And so this number for ending NFA, net fixed assets, is artificially low by the amount of depreciation, so we must add that back. And finally, we have the change in net working capital. And the change in net working capital is just the ending net working capital minus the beginning net working capital. Now, if we were being really cruel, we could point out that net working capital is equal to current assets minus current liabilities. And then we could say that this is equal to the ending current assets minus the ending current liabilities minus, parentheses, the ending or the beginning current assets minus the beginning current liabilities, close parentheses. Now let's put all of this together. We know that cash flow from assets is equal to the cash flow to the creditors plus the cash flow to the shareholders. We also know that it's equal to operating cash flow minus the net capital spending minus the change in net working capital. Therefore, we know that this must be equal to this, and so we can write it this way. Now we can expand what we just wrote out. Each of these items has an equation behind it, and so that's what we're going to do now through our substitution principle, is we will put in those equations that represent each of these items. And so now we can expand this out. Interest minus, open parentheses, ending long-term debt minus beginning long-term debt, close parentheses, plus dividends minus, open parentheses, stock sold minus stock repurchase, close parentheses, equals EBIT plus depreciation minus taxes, subtract, open parentheses, ending net fixed assets minus beginning net fixed assets plus depreciation, close parentheses, minus, open parentheses, ending net working capital minus beginning net working capital, close parentheses. So here we have the last equation from our previous slide. Let's take a look at what we can do about distributing the signs in order to get rid of all these parentheses. Okay, I'm going to draw a line here just so we don't get confused as to what is what. This is the same equation. All I've done is distributed the signs. And so now we have minus ending long-term debt plus beginning long-term debt minus stock sold plus stock repurchased. We also have negative ending net fixed assets, positive beginning net fixed assets, negative depreciation, negative ending net working capital, and positive beginning net working capital. And something interesting happens here. We have a positive depreciation and a negative depreciation, and those things are actually able to cancel out. So that simplifies it just the slightest little bit. Here we have our final version of the equation once we've distributed the signs and canceled out terms that can be canceled. Is simply interest minus the ending long-term debt plus the beginning long-term debt plus dividends minus stock sold plus stock repurchased is equal to the earnings before interest and taxes minus the ending net fixed assets plus the beginning net fixed assets minus the ending net working capital plus the beginning net working capital. Wow. That is a long equation, but the good news is now that you have this, you can solve it for any single one of these terms as long as you remember to do the same thing to both sides of the equation. If you're going to add ending net long-term debt, do it to both sides. You could also think of it this way. If I move ending long-term debt to the other side of the equal sign, I simply have to change its sign. We could do that with any one of the variables here. I could move beginning net working capital to the other side of the equal sign and just put a negative sign in front of it. And that's how we work to get any single one of these variables by itself, which is, of course, the goal in algebra.